Good? Good? Okay. Like I was saying, my name is Scott Henson, production engineering at Facebook, doing security. And today I'm going to be talking about SSH at scale, how we do authentication and authorization for SSH. It's interesting working at Facebook because some of the simplest problems can become very complex, including keeping my phone out of my pocket so that it doesn't interfere. So let's just start out with some traditional SSH. We all know this pretty well. You take a single machine that you're administering, or maybe you and a friend are administering, and you just, local accounts, you have your SSH key there, and you're able to get in just fine. Super easy. Maybe you set up sudoers with individual accounts so everyone gets root or everyone gets the appropriate permissions. Pretty easy, pretty straightforward. Then you go to most, I guess, enterprises where you have, or most big clusters where you have lots of machines, many administrators. So what you have to do is figure out how to get that authentication information out. So generally that's going to be either a shared password, an SSH key, something like that, or you go up to the KDC, Kerberos, and LDAP route. Again, pretty easy. Most people know this. There's plenty of tutorials how to do this online. I think most people are pretty good with this. What's wrong with those traditional methods? Shared key material is bad. Anytime you have a shared password or a shared SSH key or anything else shared, it's hard to know exactly who's logging in. Many moving parts. I think that anyone that has set up LDAP with NSS LDAP knows that NSS LDAP will always find a new way to break. Every other day, you have something, maybe a connection lost to your LDAP server, and suddenly your entire server is misbehaving in new and interesting ways. Then we go down to the authorization point, where you get things like authorized keys and K5 login, where you have to figure out who gets put into which server's authorized keys or who gets put into which server's K5 login. This can become a huge headache because generally that requires your configuration management system, and your configuration management system is difficult for many people to understand. And then you end up with these little bits all over the place. It ends up really poorly. These problems get even worse when you have N different authorization zones, M engineers, and then you have to combine those where they can number in the hundreds and thousands. An authorization zone is something that I use for, and I'll use in the rest of the presentation for, a group of servers or services that you have to get into. Pretty straightforward, and it really starts getting out of hand at that level where you have hundreds and thousands of different permutations. And it becomes a very big headache. So what are we going to do? So we have some requirements here that we went through. Obviously, no shared key material passwords, so that's something that we can't have in our environment because, like I said, you can't figure out who's getting in. Has to be easy to administer. Managers are generally the ones that are doing authorization choices in most environments, so the thing has to be easy for managers to understand, and we're pretty stupid, so that's a pretty big thing. As few moving parts as possible. So we want to be able to SSH into our machines even when other major parts of our infrastructure are down. This is a fairly huge deal because, as I said before, LDAP can go down, Kerberos can go down. Anything that your server depends on can go away, and so you need to make sure that your main entrance for administration is as rock solid as possible. And then the last point, can it support our massive infrastructure? You might have heard this yesterday. We have hundreds of thousands of machines across many data centers, and then we have, I don't know how many thousands of engineers that are working on those things, each of them requiring different access levels. And these are important because we don't want, both from the employee abuse perspective and from the intruder perspective, if someone's getting in, we don't want them to be able to have the keys to the kingdom from compromising a single account. So this is what we came up with of our architecture. We call this internally root canal. But basically what happens is, at the beginning of every authorization, or at the beginning of any session, basically when you come in for the day, you'll make a request against our certificate authority server. And what that'll do is it'll authenticate you. Then it'll query our ACL store and try and figure out what permissions that you should have in the infrastructure. Once it determines that, it inserts those permissions into a certificate that it then hands back to the engineer's machine. at which point, for the rest of the day, the engineer can use that certificate to go out and SSH into any single server. At that point, the server doesn't need to contact any external source to do authentication or authorization. It just automatically knows based upon what's in your certificate. So let's go over, oh yeah, also another interesting thing of this, as your ACLs are updated, we can go and request a new CA and throw away the old one, throw away the old key as well. Because we're not propagating anything around, the keys are now cheap and we can do interesting things there. So how do we do it? We basically use OpenSSH certificate authority authentication. This is something that's been in OpenSSH since 5.4. It's been pretty usable since 5.6. We currently use, I believe, 6.0, so if things don't work for an older version, go ahead and upgrade for many different reasons. So in particular, how we did it. Well, first, you have to generate your SSH CA. Passwordless, obviously, because we're going to have an automated service doing the using it, so we don't want it to have to use a password. And this just looks like a normal SSH key pair. You get a .key and a .key.pub. Pretty simple, straightforward. Then each day, we have a system where you just type this in, so you don't have to remember all this, but basically you end up with doing an SSH key gen onto a tempfs file system to get a new SSH key pair and an SSH pub. You take the pub, you ship it off to the CA. Like I said before, the CA does authentication to make sure that the person requesting it is who they say they are, and then checks with the authorization store to figure out what they should have, and then finally it signs the keys. And so what it's basically doing is it's inserting who you are, so that last, so if you look at the command line, I put in the identity as the user, and then I put a bunch of principals in here. So root at web, group engineers, group users. So these are all ACLs that can be used for authentication later on. And you see they end up in the principal section here below. We can set the lifetime down real low, 2 weeks for things that we don't really want to renew that often, but we can make it as short as 8 hours or 12 hours depending on how long the engineers work for. So as I said before, this makes the keys really cheap, so we rotate them on a regular basis. So on the server side configuration is actually fairly easy. 4 lines in the server side SSHD config. So you get the SSHCA, which is just the .pub of the certificate of the key pair that we generated earlier, where to find the authorization information, and then some revoked keys and that kind of thing. Here is the actual auth principles root file on my dev server. It includes me, because it's my personal dev server. And then it contains people that can log into dev, and then some other group information, and then a root super. That root super is actually pretty interesting, and I'll go into it later. So what did we get? SSH certificate requested once per expiration period, or when the ACLs change. Like I said, for the entire period that that SSH cert is valid, you don't have to worry about talking to anyone else. You have your authentication ticket to be able to go anywhere in the infrastructure that you're authorized to go to. We get granular permissions that are stored in the certificate itself, and that the servers don't really have to know about all the permissions that you have. They just have to know that root at web part. And so that lets us do any different permutation of any of our different authorization zones to be able to get you into those things without any of the individual servers contacting anything externally or knowing anything about any other authorization zone. All key material is obviously unique. Like I said, we regenerate it. Every time you make a request for a new certificate, we regenerate the key. And as I said, SSH server has all the information to do the authentication and authorization, which is very key to our setup. So yeah, granular permissions. So one big thing with all security is everyone wants to have all the access that they think that they need all the time, which sounds good up front, but from a security perspective, if you have more access than you actually need, that causes problems from a security perspective, because then obviously you're getting into places you can, and then if an attacker compromises your account, they get much broader access than they actually should have gotten. So what we did, we have an easy permission request workflow that just basically makes it very easy for both you to request that flow. So what you do is whenever you get a permission denied from a server, you get a nice little link. It's nice and easy. You click on it, tell the person why you want it, and then you can get access. And also it's in the generalized ACL management system, so everyone is familiar with it because everyone uses the same ACLs. Another cool thing, and this is about the root super principle that I was talking about earlier. Sudo. We all use sudo every day. Sudo is a good thing. We're all told never start anything as root if it doesn't need those root privileges. So you don't log into your systems as root, you sudo for the specific things that you need to do, and you try and limit the permissions that you have. And also sudo provides some authentication to make sure that the person that's sitting at the terminal is the person with those accesses. So sudo is a very nice thing that wasn't really in any of the Kerberos or LDAP implementations that we were seeing, and not really in any of the others. But because we can re-request principals or re-request a certificate at any point in time, what we came up with is SUSH. So you request access to servers that you wouldn't normally have access to, and you elevate your privileges with SUSH. It does a two-factor authentication, it's logged, it's audited, we ask you why you're wanting to log into those systems, and the service owner of the authorization zone can opt out if they need to for whatever reason. But the most important part is we know who is doing it, we know why they're doing it, and we know what they're doing. And so we can give the individual engineers access where they need it, but still maintain that extra level security. A good example of this was yesterday with Igor, where he was talking about McRouter. McRouter runs everywhere in our infrastructure because everything needs access to cache. So normally in a system like most SSH setups, most authorization setups, we would need to give Igor access to everything. But with the SuperCert setup with SUSH, we can actually just give Igor access to the exact machines that he needs to, when he needs to, for a short period of time, and then he loses those permissions. So he has at least permission possible at all times, and then gets it whenever he actually needs it. Maintaining ACLs is very important in a system like this. People tend to collect access over time. They just, for one day, they need it, and then they just continue on with it forever. That's not really all that great, so we need a place where we can get all ACLs, we can look at them, see exactly who has what access, and pull that apart, and look at who's using that access via our logging, and then make decisions about when to remove access and when to grant it. Also, as part of the granting, we provide information about the user that's accessing it, who they're reporting to, what organization they're in, what groups they're in, why they're accessing it, and then we can, that way the person granting the access, which is not us, which is not the security organization, ends up knowing whether or not to give that access out. So, conclusions. Like I said, big thing, no shared key material anymore. Very easy to administer. Like I said, managers are stupid, so we have to make sure that this is idiot-proof. As few moving parts as possible. Our configuration management system lays down a fixed set of principles, and then it's done, and then you get those principles and you're able to get in and whatnot. And can support arbitrary number of authorization domains with many different users, because you only get a fixed number of principals in your certificate without knowing about all the other authorization zones, and the host that you're logging into only has the principals that it needs to know about. All right, thank you. Any questions?